Our aim is to achieve dynamic formation tracking in multi-agent systems using local bearing information. Typically, formation control assumes a rigid communication graph that is preserved throughout the entire operation. However, this limits its applicability when we face real-world sensing constraints. Therefore, our approach introduces two key objectives. 1. Ensuring bearing rigidity in the communication graph without assuming it exists. And 2. Achieving dynamic formation tracking defined specifically using bearings. We can observe agents in a leader-follower framework categorized into layers, where the first layer is composed of leaders. We consider the sensing range as the criterion for communication between agents. Next, we will show how, given a non-bearing rigid graph, our controller enables agents to recover a bearing rigid graph in finite time. Initially, the communication graph is not bearing rigid. As we can see, the active edges, shown in layer colors, do not fulfill the criterion for bearing rigidity as the required edges, in red, which ensure each follower has at least two parents, are missing due to sensing range limitations. Now we will show, having achieved bearing rigid graph, how a dynamic formation as shown for desired is tracked by the agents. We solve a QP problem for each agent respecting the heading-based control barrier function like constraint, which dynamically tracks moving formation. Next, we will change the desired formation, defined using desired bearings, for formation maneuvering. We will observe that as the leaders reverse their movement direction, having reached the arena boundary, a new desired formation is being tracked by the agents. This showcases the real-world applicability with sensing range limitations.